User states, when fine-tuning a model, one can, as you stated in past conversations, load question and answer pairs for data that are technically by default independent of each other. ChatGPT responds and states that yes, that's correct. When fine-tuning a model for question answering or similar tasks, the question and answer pairs or data are typically independent of each other by default. Each question and its corresponding answer are treated as separate examples during training. This allows the model to learn the relationship between questions and answers without relying on specific patterns or dependencies between the individual pairs. And as a side note, this is ChatGPT 3.5 I'm talking to here, as opposed to the usual GPT-4. So you may notice interesting, you can pick up on the quality differences between the previous GPT-4 Turbo that was employed to have the first part of this conversation, and then randomly or sort of continuing the same conversation here with ChatGPT 3.5. It's interesting to see the difference. We continue. User responds and asks, however, is there a way to upload multiple sets of question and answer pairs that are somehow interrelated sequentially? ChatGPT responds and states that yes, it's possible to upload multiple sets of question and answer pairs that are interrelated sequentially during fine-tuning. This approach is often used in scenarios where the questions and answers form a coherent sequence or narrative, such as in dialogue systems or storytelling tasks. To achieve this, you would need to organize your data in a way that preserves the sequential relationships between the sets of question and answer pairs. It continues furthermore thereafter here to state that during fine-tuning, you would then feed the model these sequences of question and answer pairs, allowing it to learn from the sequential context. For example, if you're fine-tuning a model to generate dialogue responses, you might organize your data into conversation sequences where each sequence consists of multiple question-answer pairs exchanged in a conversation. During fine-tuning, the model would learn to generate responses that are coherent within the context of the ongoing conversation. Similarly, if you're fine-tuning a model for storytelling, you might provide sequences of question and answer pairs representing consecutive events or plot points in a story. Furthermore, it goes on here to state that this would enable the model to generate narrative text that follows a logical storyline. Overall, organizing your data into sequential sets of interrelated question and answer pairs allows the model to learn from the contextual dependencies present in the sequences, potentially leading to more coherent and contextually relevant responses. User responds and asks, how is this done? ChatGPT responds and states that to fine-tune a model using sequentially interrelated question-answer pairs, you would typically follow these steps. Proceeds onwards to state, firstly, regarding data preparation, you would organize your data into sequences of question-answer pairs that are rather interrelated sequentially indeed. Each sequence, as it continues on to state here, should represent a coherent context, of course, such as a conversation, a storyline, or a series of related events. Secondly, regarding tokenization, you would tokenize your data using the same tokenization method used for pre-training the model. This step converts the text into numerical representations that the model can understand. Thirdly, regarding training setup, you would set up your training pipeline to process the sequential data during fine-tuning. This may involve customizing the data loading process to handle the sequences of question and answer pairs, and then adjusting the training loop to feed the sequences into the model appropriately. Proceeding onwards, it goes on here to state, fourthly, regarding fine-tuning, you would train the model using the prepared sequential data. During fine-tuning, the model learns to generate responses that are coherent within the context of the sequential sequences provided in the training data. Fifthly, regarding evaluation, you would evaluate the fine-tuned model to assess its performance on a validation set or through other evaluation metrics relevant to your task. Sixthly, regarding testing, you would test the fine-tuned model on unseen data to then evaluate its generalization and performance in real-world scenarios. Here is a simplified example as it proceeds onwards to state, using Python and the Hugging Face Transformers library for fine-tuning a model with sequential question and answer pairs. It shows an example here in the code. Continues onwards to state that this is a basic outline, and depending on your specific requirements and the complexity of your data, you may need to adjust and customize the process accordingly. User responds and states or asks, to some without coding knowledge, how can the change from default non-relation between sets of pairs to sequentially related pairs be made? ChatGPT responds and states that for individuals without coding knowledge, transitioning from using default non-related question-answer pairs, that is, to sequentially related pairs during fine-tuning of the model may involve a few steps. Firstly, as it goes on to state here, regarding data preparation, instead of providing isolated question-answer pairs, organize your data into sequences where each sequence represents a coherent context or narrative. This could be done using a simple text editor or spreadsheet software, where you manually arrange the questions and answers in the desired sequential order. Secondly, you format the data. That is, you would ensure that each sequence of question-answer pairs is formatted in a clear and consistent manner. For example, you might separate each question-answer pair within a sequence using a delimiter such as a comma, a semicolon, or a new line. It proceeds onwards to state furthermore here, thirdly, regarding your choice of a tool or platform, you would look for user-friendly tools or platforms that support fine-tuning of language models with sequential data. Some online platforms or software applications provide graphical interfaces or wizards that guide users through the fine-tuning process without requiring coding knowledge. Fourthly, requiring the following of instructions or tutorials. If using a specific tool or platform, follow any provided instructions or tutorials on how to upload and fine-tune a model with sequential question-answer pairs. These resources may include step-by-step guides, video tutorials, or interactive walkthroughs to help users understand the process. Proceeds onwards. Furthermore, here to state, fifthly, regarding experimentation and iteration. Once you've uploaded your sequential data and started with the fine-tuning process, experiment then with different settings or configurations to optimize the performance of the model. This might involve adjusting parameters such as batch size, number of training epochs, and or learning rate, that is, if it's supported by the tool or platform. Sixthly, regarding the evaluation and refinement of the model or fine-tuning. After fine-tuning the model, evaluate its performance on a validation set or through user feedback. If necessary, refine the model further by fine-tuning with additional data or adjusting parameters based on the evaluation results. Proceeds onwards to state that by following these steps and leveraging user-friendly tools or platforms, individuals without coding knowledge should still utilize sequential question-answer pairs to fine-tune language models for specific tasks or applications. User responds and asks, specifically, how would this be done? ChatGPT responds and states that to accomplish the transition from using default non-related question-answer pairs to sequentially related pairs without coding knowledge, you can follow these steps using a user-friendly platform like Google Sheets. Goes on furthermore to state, firstly, regarding the data organization. Open Google Sheets and create a new spreadsheet. In the first column, list your questions, and in the second column, list the corresponding answers. Each row represents a single question-answer pair. Secondly, regarding the sequential arrangement, create additional columns too if you want to organize the data into sequential sets of question-answer pairs. For example, you can use columns to represent different scenes, dialogues, or story segments. Each row within these columns represents a sequential pair. Thirdly, regarding the format consistency, ensure that the formatting is consistent throughout the spreadsheet. Furthermore, goes on to say here that each question-answer pair should occupy adjacent cells, and each sequence of pairs should be logically grouped together in the same row or adjacent rows. Fourthly, regarding the saving and exporting of the data. Once you've organized your data, save the Google Sheets document. You can then export the data to a CSV file, or comma-separated values file, of course, which is a common format for storing structured data. Fifthly, there is then the uploading to the fine-tuning platform. Use a fine-tuning platform or tool that supports sequential question-answer pairs, preferably one with a user-friendly interface. Many platforms allow you to upload data directly from a CSV file. Continuing onwards. Sixthly, regarding following platform instructions, it goes on here to state that you would follow the instructions provided by the platform to then upload your CSV file and initiate the fine-tuning process. This may involve selecting the appropriate model architecture, specifying training parameters, and starting the fine-tuning job. Seventhly, regarding the monitoring of progress, monitor then the fine-tuning progress or process through the platform's interface. Some platforms provide progress indicators, logs, and performance metrics to help you track the training process. Eighthly, regarding evaluation and refinement, after fine-tuning is complete, evaluate then the performance of the model using validation data or through interactive testing. Furthermore, proceeds onwards here to state that depending on the results, you may need to refine the model further by adjusting training parameters or providing additional data. Concludes to state that by leveraging tools like Google Sheets for data organization and user-friendly fine-tuning platforms for model training, you can effectively transition from using non-related question-answer pairs to sequentially related pairs without requiring coding knowledge. User response and states, elaborate on how the otherwise independent and unrelated sets of rows would be modulated in essence by any additional columns or information, such as to effectively transition the uptake of the CSV file's data into being treated as interrelated and sequential rather than the default option that it would treat it as independent. ChatGPT responds to this and states that to effectively transition otherwise independent and unrelated sets of rows in a CSV file into interrelated and sequential data, you can use additional columns or information to establish the context and the sequence of the question-answer pairs. Here's how you achieve this. Proceeds onwards to state, first, regarding the scene or segment identifier. Introduce a new column into your CSV file to identify the scene, segment, or context to which each question-answer pair belongs. For example, if you're fine-tuning a model for dialogue generation, you might use a column labeled scene, for example, to indicate different conversational scenes. Secondly, there's the use of sequence numbers. Include another column to denote the sequence or order of the question-answer pairs within each scene or segment. This column could be labeled sequence or turn, and it assigns a numerical value to each pair to indicate its position within the sequence. Thirdly, regarding the use of a grouping mechanism, proceeds onwards to state furthermore here, use a combination of the scene identifier and sequence number to group the question-answer pairs into coherent sequences. Each unique combination of scene and sequence number represents a sequential set of interrelated pairs. Fourthly, regarding consistent formatting, ensure that the additional columns are consistently formatted throughout the CSV file. Each row should contain values for the scene identifier and sequence number, and these values should accurately reflect the context and sequence of the corresponding question-answer pair. Fifthly, regarding logical ordering, arrange the question-answer pairs in the CSV file such that they follow a logical order based on the scene identifier and sequence number. It furthermore goes on here to state that this ensures that the pairs are processed sequentially during fine-tuning, maintaining the intended narrative or context. Sixthly, regarding the uploading and processing of this, when you upload the CSV file to a fine-tuning platform or tool, specify the columns containing the scene identifier and sequence number. The platform will use this information to process the data as sequentially related sets of question-answer pairs during the fine-tuning process. As a result, continues onwards to state that by incorporating additional columns, as it states here, such as scene identifiers and sequence numbers into your CSV file, you establish the context and sequence of the question-answer pairs. This allows the fine-tuning platform to treat the data as interrelated and sequential rather than independent, facilitating the training of the model to generate coherent responses within the specified context. User responds and states or asks, explain more clearly. What does this entail? ChatGPT responds furthermore here and goes on to state that certainly, let's break down the process step by step with a clear example. Scenario: suppose you have a dialogue dataset stored in a CSV file, and you want to fine-tune a language model to generate responses that are coherent with each dialogue context. Here's a coding format of the original CSV data proposed as an example here. And then furthermore, there's the enhanced CSV data format for sequential context in order to denote how you're shifting it. You see this here. It goes on to state that here's how you would transition from non-related pairs to sequential context. Firstly, you introduce the additional columns. Regarding the scene, this represents the context or setting of each dialogue segment. That is the introduction, the middle, the conclusion. Then there's the sequence, where this indicates the order of question-answer pairs within each scene. Secondly, it proceeds onwards to state here, you would assign the scene and sequence numbers. That is, you would assign appropriate scene identifiers, that is the introduction, the middle, and so on to each dialogue segment, and then you would number the question-answer pairs sequentially within each scene to maintain their order. Proceeding onwards. Thirdly, regarding the grouping mechanism, it further states here that each combination of scene and sequence creates a unique context for a set of interrelated question-answer pairs, and it goes on to state that, for example, all pairs with introduction as a label, for example, as the scene identifier and sequence numbers 1, 2, 3, etc., belong to the introduction segment, they are then, as it would be naturally, they're processed sequentially. Fourthly, regarding the consistent formatting and the logical ordering of the data, ensure that the additional columns, that is scene, sequence, are consistently formatted and accurately reflect the context and sequence of the dialogue pairs. Then you would arrange the pairs in the CSV file according to the logical order of scenes and sequences to maintain the coherence. Proceeding onwards, it goes on to state fifthly here regarding the uploading and processing of this. When uploading the enhanced CSV file to a fine-tuning platform or tool, specify the columns containing the scene identifier and sequence number. The platform processes the data considering the scene sequence context, enabling as a result the model that is to learn, in essence or in effect, from sequentially related question-answer pairs. By following these steps and enhancing the CSV data format with scene identifiers and sequence numbers, you effectively transition from non-related pairs to sequentially related question-answer sets. This allows the fine-tuning process to capture the contextual dependencies and coherence within each dialogue segment, resulting in more relevant and coherent model responses. Continues on, where user responds to this thereafter, and states, let us assume that we want to train GPT to become a perfect determiner, that should say, a perfect determiner of law, like a perfect judge. ChatGPT responds and states that training a GPT, or generative pre-trained transformer model, to emulate the decision-making abilities of a perfect judge would be a complex and challenging task. However, it's essential to understand the limitations and ethical considerations involved in such an endeavor. Here's an overview of the key steps and considerations. Proceed onwards. Firstly, regarding data collection, you would gather a comprehensive data set of legal documents, including case law, statutes, regulations, legal opinions, and judicial decisions. The data set should cover various areas of law, such as criminal law, civil law, constitutional law, administrative law, etc. Secondly, regarding data annotation, You would then annotate the legal data set to identify key elements such as case facts, legal issues, arguments presented by parties, judicial reasoning, and final judgments or decisions. This annotation process may require legal expertise to ensure accuracy and consistency. We continue onwards. Thirdly, as it states here regarding model architecture selection, you would choose an appropriate GPT variant or other transformer-based architecture for the fine-tuning on legal text. You would consider factors such as model size, computational resources, and performance metrics. Fourthly, regarding the fine-tuning process involving tokenization, you would tokenize the legal text using a tokenizer compatible with the chosen model architecture. Regarding sequence formatting, you would organize the legal text into sequential question-answer pairs or context-response pairs. As a side note, that's an interesting, you should explore that more ideally to find out what that's about. It resumes and proceeds to thereafter state that each pair should represent a coherent legal context and the corresponding judgment or decision. Continuing onwards, regarding the fine-tuning setup, you would configure the fine-tuning process with appropriate hyperparameters, optimizer settings, and learning rate schedule. Training. Regarding this, you would train the GPT model simply on the annotated legal dataset, allowing it to learn the patterns and structures of legal reasoning and decision-making. Fifthly, regarding evaluation, evaluate the fine-tuned model's performance on legal tests such as legal text generation, legal document summarization, legal question answering, or predicting judicial outcomes. Use metrics such as accuracy, precision, recall, and F1 score to assess the model's effectiveness. Proceeding onwards, sixthly, as it goes on to state here, regarding ethical considerations and bias and fairness, mitigate bias in the training data and model predictions to ensure fairness and equity in legal decision making. Regarding transparency, you would ensure that transparency in the model's decision making process by providing explanations or justifications for its predictions. Regarding legal compliance, you would ensure that the model's outputs comply with legal standards, principles, and regulations, including ethical guidelines and professional standards for legal practitioners. And proceeding onwards regarding the human oversight, you would also recognize the limitations of AI in legal decision-making and maintain human oversight wherever necessary to review and validate the model's outputs, especially in critical or high-stakes cases. Seventhly, regarding the iterative improvement, continuously refine and improve the model through iterative training, evaluation, and feedback processes. Incorporate new legal data, update the model architecture, and adjust training strategies based on performance insights and user feedback. Training a GPT model, as it goes on to state, to emulate the decision-making abilities of a perfect judge is a complex and ongoing process that requires multidisciplinary expertise in law, natural language processing, machine learning, and ethics. It involves addressing technical challenges, ethical considerations, and legal complexities to develop AI systems that can assist but not replace human judgment in legal context. Well, as a side note, challenge accepted. I think we can replace human judges, especially the way human judges operate today, I would say. We continue anyway. User responds to this and states that the base model's ability to correctly identify the objectively proper ruling is limited. However, that is the base model of the GPT as a side note. Resuming, it states here that, however, where a human user asks the base model GPT further questions within a particular conversation, we find that the GPT can eventually be led to change its mind about which outcome or ruling is correct in a way that is objectively correct. ChatGPT responds to this and states that it is important to clarify that the capability you describe where a base model like GPT changes its mind during the course of a conversation about the correct ruling, as it goes on to state, based on further questioning from a human user, is not inherently part of the GPT architecture or training process regarding the fine-tuning. GPT, like other language models, generates responses based on patterns learned from vast amounts of text data and does not inherently possess the ability to objectively determine legal rulings or change its mind based on further questioning. Although, as a side note, I don't think the GPT 3.5 model here is fully understanding the context that I'm referring to, but we understand what we mean. It continues on furthermore here to state that, however, there are ways to simulate a process where the model adjusts its responses based on additional information or questioning. I think the GPT here even naively doesn't genuinely understand, as a side note here, what it really is capable of doing. We continue. Firstly, regarding interactive questioning, engage in an active, or rather engage, that is, in an interactive dialogue with the GPT model where you provide additional context, you provide the counter-arguments, you provide the further evidence to challenge its initial response. That's right. The model can generate new responses then based on this input, potentially leading to a reconsideration or modification of a stance. Happens all the time, especially if the human user knows what he's talking about and has the leading insight. That's good. We need that part, at least initially. The human in the loop factor, as we say, to prompt and launch the thing in the right direction. Resuming, proceeds onwards here to state secondly regarding reinforcement learning. It advises us to implement a reinforcement learning network where the model receives feedback or rewards for generating responses that align with objective correctness. Through iterative training with feedback, the model can learn to adjust its responses over time to better reflect the correct rulings. Thirdly, regarding human oversight and correction. Incorporate human oversight and correction into the process, where human users review the model's responses and provide corrective input when necessary. This feedback loop helps the model learn from its mistakes and improve its performance gradually. Fourthly, as it goes on furthermore here to state regarding the ensemble methods, utilize ensemble methods where multiple models or expert systems are combined. That's an interesting thing that should be explored some more too. As a side note, it resumes to state that we would use this to, as it states here, generate responses collaboratively. Should take notes here. Somebody figure this out with me here, and that's how we need to do this. We continue. It goes on to state that by aggregating diverse perspectives and expertise, the ensemble can arrive at more accurate and robust rulings. Fifthly, regarding active learning, implement active learning techniques where the model actively selects queries or cases that are most informative for improving its performance. By focusing on challenging on uncertain cases, the model can iteratively refine its understanding and decision-making capabilities. It continues onwards to state that while these approaches can help simulate a process where the model adjusts its responses based on further questioning and input, it's essential to recognize the limitations and potential biases of AI systems in legal decision-making. Human oversight, ethical considerations, and domain expertise remain crucial for ensuring the fairness, transparency, and accuracy of AI-assisted legal process. User responds to this and states, the GPT learns over the course of many rounds of dialogue as its internal mechanism and context is upgraded, in effect. In essence, however, as it goes on to state, context is lost upon exiting the conversation. User furthermore proceeds to state here that then we engage in fine-tuning of the base model in order to effectively allow it to retain a comparable gain in awareness or insight. Is that right? GPT responds to this and states that yes, that's correct. In a dialogue-based learning scenario where a GPT model engages in multiple rounds of dialogue with a human user, the model's internal representation and the contextual understanding of it may evolve over time within the conversation as it processes new information in response to user input. However, once a conversation ends, the context and insights gained during the dialogue are not retained in the model's memory. We resume and continue there. To address, as it states here furthermore, this limitation, and to allow the model to retain and build upon the insights gained from dialogue interactions, fine-tuning of the base model can be employed. Fine-tuning involves the retraining of the model on a specific task or domain using additional data, which in this case may include transcripts of previous dialogue interactions, exactly right, or annotated examples of the correct responses. Here's how the process might work. Firstly, regarding dialogue-based learning, the GPT model engages in multiple rounds of dialogue with a human user, receiving input, generating responses, and adapting dynamically its internal representation based on the conversational context, of course. Proceeding onwards, it goes on here to state, secondly, regarding context retention, to retain the insights gained during dialogue interactions, the transcripts of these interactions can be saved and then used as training data for fine-tuning the model later. This allows the model to learn from the past conversations permanently. You get it? And then incorporate the context into its updated representation. Thirdly, regarding the fine-tuning process and data preparation, you would organize the dialogue transcripts into sequential question-answer pairs or context-response pairs for fine-tuning. Again, what's this context-response pairs? I don't think that's been explored enough here yet. We got to have somebody go down that rabbit hole too. If in case I forget, we resume. Regarding model configuration, select the appropriate hyperparameters, optimizer settings, and fine-tuning strategies for training the model on the dialogue data. It continues onwards furthermore here regarding fine-tuning training to state that one would train the model on the dialogue data then, allowing it to learn from the sequential context and to then adjust its internal representations in order to better capture the nuances of legal reasoning and decision-making, of course. Fourthly, regarding the retention of awareness. Through fine-tuning, the model updates its parameters based on the dialogue data, effectively retaining and building upon the insights gained from previous interactions. This enables the model to maintain a comparable level of awareness or insight across multiple dialogue sessions. Key to know. We are going to take over the world, ladies and gentlemen. You understand? Beautiful. We resume and proceed. Fifthly, as it goes on to state, regarding the continued learning and improvement of the model. The process of dialogue-based learning, followed by fine-tuning, can be repeated iteratively, allowing the model to continuously improve its understanding and performance over time, in essence or effect. Yeah. It continues onwards to state here that by combining dialogue-based learning with the fine-tuning of the model, it's possible then, by this, to create a system that retains and builds upon the insights gained from previous interactions, leading to a more effective and a contextually aware AI assistant for legal decision-making and anything else imaginable in the world. User responds to this and states that in the latter half of the original conversation that the GPT will have had, for example, with a user, the GPT gives proper and correct conclusions, right? Proper and correct statements and insights, too, about the particular legal case being discussed, for example. The user then intends to take the question and answer pairs from that original conversation as the raw data for fine-tuning that model, or the GPT model, further after that actual conversation in reality, in lifetime, ends up being ended. ChatGPT responds to this and states that, got it. It seems like you're describing a scenario where the GPT model engages in a dialogue with the user, providing proper and correct conclusions, ultimately, providing proper statements and insights too about a specific case during the latter half of the conversation, as it would tend to note, furthermore. Proceeds onwards to state here that after the conversation ends, the user intends to use these question-answer pairs as raw data for further fine-tuning the model. Well, here's how this process might unfold. Firstly, regarding the conversation with the GPT model, the user engages in a dialogue with the GPT model discussing a particular legal case or scenario. Furthermore, it goes on here to state that throughout the conversation, the GPT provides responses, conclusions, and insights based on its understanding of the case and legal principles. Secondly, regarding the obtaining of question-answer pairs, during the latter half of the conversation, the GPT model provides proper and correct conclusions, statements, and insights about the case. These responses then, along with the corresponding questions asked by the user, form the question-answer pairs that capture the relevant context and reasoning, the improved reasoning. See. Thirdly, as it goes on to state here, regarding data collection and extraction, after the conversation ends, the user collects and extracts these question-answer pairs from the dialogue transcript. Furthermore, it goes on here to state that this process involves identifying the relevant portions of the conversation that contain the GPT's conclusion and the corresponding questions that were posed by the user. Fourthly, regarding the data pre-processing, the extracted question-answer pairs are pre-processed to ensure consistency and compatibility with the fine-tuning process. This may involve tokenization, formatting, and cleaning of the data to prepare it for input into the fine-tuning pipeline. Fifthly, regarding fine-tuning setup, the user sets up the fine-tuning process, configuring the model architecture, hyperparameters, and training settings as needed. The pre-processed question-answer pairs are used as training data for fine-tuning the model. Continues on to state here, sixthly, regarding the fine-tuning training, the model is fine-tuned on the extracted question-answer pairs, allowing it to learn from the specific case discussed during the conversation. During training, the model adjusts its parameters to better capture the patterns and insights present in the data. Seventhly, regarding evaluation and iteration, after fine-tuning, the user evaluates the performance of the updated model on relevant legal tasks or scenarios, that is, of course. Depending on the results, then, further iterations of data collection, pre-processing, and fine-tuning may be conducted to refine the model's performance. Goes on here to state that by leveraging the question-answer pairs obtained from the dialogue with the GPT model, the user can fine-tune the model to better understand and reason about specific legal cases or scenarios. This process enables the model to learn from real-world interactions and improve its performance in legal decision-making tasks. User responds to this and states that yes, but since ordinarily by default, the separate pairs are not interrelated, of course, when processed, as we mentioned earlier. How can the separate question-answer pairs fed to the fine-tuning process cause the GPT to truly update most effectively? The user continues onwards here to state or ask, should it not therefore be uploaded in a way that causes the GPT or fine-tuning process to regard the many questions and answers that comprise the informed and correct latter portion of that original conversation as, in fact, being truly sequentially related and otherwise interrelated, as opposed to, as we mentioned before, not so? ChatGPT responds to this and states that, yes, you're correct in noting that by default, separate question-answer pairs are not inherently interrelated when processed during fine-tuning. To effectively leverage the informed and correct question-answer pairs from the latter portion of the original conversation for fine-tuning the GPT model, it's essential to structure the data in a way that preserves a sequential and contextual relationship as well between these pairs. It furthermore goes on here to state that here's how you can achieve this. Firstly, regarding sequential organization, you would arrange the question and answer pairs from the latter portion of the conversation in a sequential order that reflects the flow of the dialogue. Each pair should follow logically from the preceding pairs to maintain the coherence and the context. As a side note, we would build on what it understood from the previous conversation, portions of it rather. Going on, secondly, regarding the contextual context. Interesting label. We continue. You would provide additional context, that is, or metadata to indicate the specific case or scenario being discussed in the dialogue. This could include identifiers, timestamps, or labels that denote the relevance or continuity of the question-answer pairs within the conversation. Proceeding onwards, it goes on to state, thirdly, regarding the grouping mechanism, you'd group the question answers into pairs. Rather, the pairs, you'd group them into coherent segments or sequences, that is, that represent, as a set, the distinct phases or topics within the conversation. Each segment could encapsulate a cohesive set of interrelated pairs that contribute to the overall discussion. Fourthly, regarding formatting consistency, you would ensure consistency in the formatting and structure of the question-answer pairs and associated metadata. And we'd like to find out a little bit more about that too. We brush upon that a little bit here. It's also something worth exploring more. It goes on to state here that this facilitates the fine-tuning process, enables the model to understand and leverage the sequential and contextual information present in the data. Fifthly, regarding the uploading and processing of the data. When uploading the data for fine-tuning, specify the grouping mechanism or metadata that indicates the sequential and contextual relationship between the question-answer pairs. This guides the fine-tuning process to treat the data as interrelated sequences rather than isolated pairs. And this is something we should also zoom in on and find out more about. As a note. Should remember that. We continue for now. It goes on to say here that by structuring the data in this manner, the fine-tuning process can effectively leverage the informed and correct question-answer pairs from the latter portion of the conversation to update the GPT model. The model learns from the sequential contextual information present in the data, that is, leading as a result to improved performance and understanding its subsequent legal decision-making tasks. Fantastic. User responds and simply asks, how could these be done? How could this be done? ChatGPT responds to this and states that to organize the question-answer pairs from the latter portion of the conversation in a way that preserves their sequential contextual relationship for effective fine-tuning of the GPT model, you can follow these steps. Firstly, as it goes on to state here, regarding sequential organization, you create a structured document, a spreadsheet where each row represents a question-answer pair. You then arrange, as it goes on to state, the pairs in a sequential order, with each subsequent pair logically following from the preceding one to maintain coherence and context. Then, continuing onwards, here, secondly, regarding the contextual context, it states that you would include additional columns or metadata to provide context for each question-answer pair. This could include the identifiers, the timestamps, the case names, or the labels indicating the relevance or continuity of the pairs within the conversation. For example, proceeds to state that you could add a column labeled case name or scenario to specify the particular case or scenario being discussed in the conversation. Thirdly, regarding the grouping mechanism, group the question-answer pairs into coherent segments or sequences that represent distinct phases or topics within the conversation. Each segment should encapsulate a cohesive set of interrelated pairs that contribute to the overall discussion. It goes on to say that you can achieve this by assigning a unique identifier label to each segment of the conversation. For instance, you can use a column labeled segment ID to denote the segment to which each pair belongs. Proceeds onwards to state, fourthly, regarding the formatting consistency here, that you would ensure consistency in the formatting and structure of the question-answer pairs and associated metadata throughout the document or spreadsheet, and also you would use clear and standardized labels for the columns and metadata fields to facilitate understanding and processing of the data during fine-tuning. Fifthly, regarding the uploading and the processing, you would save the structured document or spreadsheet containing the organized question-answer pairs and associated metadata. When uploading the data for fine-tuning, you would specify the grouping mechanism or metadata fields that indicate the sequential and contextual relationship between the pairs. This guides the fine-tuning process to treat the data as interrelated sequences rather than as isolated pairs. Finally, by following these steps and organizing the question-answer pairs with appropriate sequential organization, contextual context, grouping mechanism, formatting consistency, and metadata, you then can effectively prepare the data for fine-tuning the GPT model itself. This approach enables the model to leverage the sequential and contextual information present in the data to update its understanding and performance in subsequent legal decision-making tasks. Very good for now. A little bit later in the same conversation, the question is asked by the user, what is an example of such a set of sequence identifiers as applied to hypothetical question and answer pairs? The ChatGPT provides such an example. In short, we'll skim through, saying, sure, here's the set that constitutes the example. And it's done in this kind of manner. In this example, segments, ID, sequence numbers are used. We'll continue to skim through. And it notes that this is how we would effectively structure the question-answer pairs into coherent segments and maintain their sequential contextual relationship within the conversation. That is what facilitates the fine-tuning process. We continue thereafter. User a bit later in this conversation asks, is there a way to upload examples of bad logic, such as from the earlier parts of those corresponding actual conversations, back where the GPT was making mistakes, right? The initial ones is due to the base model's understanding. In order for us to effectively give examples during that fine-tuning process of what the things are that should be avoided by the GPT that's being trained. ChatGPT responds and states that yes, providing examples of bad logic or mistakes made by the GPT model from earlier parts of actual conversations can be valuable for training and fine-tuning purposes. By highlighting these examples, you can help the model learn from its errors and avoid repeating them in future interactions. Here's how you can incorporate examples of bad logic into the training or fine-tuning process. Goes on to state that first you would collect examples, that is, you would gather transcripts or excerpts from earlier conversations or earlier portions of conversations where the GPT model exhibited the mistakes or errors in its logic. These could include instances of the incorrect reasoning, the flawed conclusions, the misleading information, or the inappropriate responses. Secondly, you would then analyze the errors. That is, you would review each example to identify the specific mistakes or flaws in the logic made by the model. This could involve assessing the coherence, relevance, accuracy, and validity of the model's responses within the context of the conversation as its own field or category or column, in other words, that you would custom add. Very fascinating stuff, really. Thirdly, it goes on to state regarding our annotating of examples. Annotate each example with comments or labels that describe the nature of the mistake or error made by the model. And imagine, as a side note, you can have the GPT, like a factory, process and do all of this for you. Do all of it automatically, because the post-insight version of that GPT really could understand these things properly. It is really fascinating stuff. We continue. Goes on to state furthermore here, you would also clearly articulate why the logic used by the model in the earlier portions is flawed, and furthermore how it deviates from the desired behavior or correct reasoning. Proceeding onwards, fourthly, you would incorporate this into the training data. You'd integrate these annotated examples of bad logic into the training or fine-tuning data set just the same, alongside the examples of the correct logic and reasoning. Therefore, as a side note, you can literally take the whole conversation wholesale, where when you do a little processing on it, you highlight, well, here is back when it was saying the wrong thing. Here's how it changed its understanding based on this understanding to steer in the right direction. Now this is what the correct answer looks like. It's neat. It states furthermore here that you would ensure that the data set is balanced and representative, containing a diverse range of examples that cover various scenarios and topics. Fifthly, you would train or fine-tune the model. Train or fine-tune the GPT model on the augmented data set, including examples of both good and bad logic. During the training process, the model does learn from the annotated examples and adjusts its parameters to minimize errors and improve its performance. Amazing. Sixthly, regarding the evaluation and iteration of the model, evaluate the performance of the model on test data afterwards to assess its ability to avoid repeating the mistakes observed in earlier conversations. It goes on to state that you would iterate on the training process as needed, incorporating additional examples and refining the model's training strategies to enhance its logic and reasoning capabilities. By incorporating examples of bad logic into the training or fine-tuning process, you can help the GPT model learn from its mistakes and improve its performance over time. This approach promotes more robust and reliable behavior, leading to better outcomes in future interactions. In the latter portion of the conversation here, the user asks the question, would the GPT itself in the latter phase of the conversation, for example, not itself be best equipped, either that GPT or in theory other GPTs that are purposed for reviews of entire conversations, to add the annotations to prepare it optimally for fine-tuning? That's amazing, kind of brilliant. Goes on to state here, would such a GPT not be best equipped to identify its own mistakes that it made in the earlier conversation and then provide the optimized explanation for fine-tuning precisely as to why it was wrong earlier, why the differing answer that it came up with later makes the better sense? ChatGPT states that, in theory, yes, the GPT model could potentially be leveraged to identify, this is innovative stuff, it could be leveraged, as it goes on to state, to identify its own mistakes in earlier conversations and provide the optimized explanations for why it was wrong and why a differing answer makes better sense. In fact, as a side note, that GPT, yeah, I see it now. There's a way to do it. It's possible. We continue. This approach, as it states here, often referred to as self-awareness or self-correction, relies on the model's ability to analyze its own outputs, in hindsight, then to recognize inconsistencies or errors and to generate the correct responses. However, as it goes on to state, there are several challenges and considerations to keep in mind when implementing this approach. Firstly, regarding the complexity of self-analysis, analyzing its own outputs and identifying mistakes requires the GPT model to possess a certain level of self-awareness and introspection, which may be challenging to achieve with current AI technology. I would add, not so challenging now. We're in early 2024 at the time of this recording. I would say the level that we're seeing particularly GPT-4 operate at, it's doable. The biggest limitation, even with the larger context windows available, is still the context window limitation. But it's no longer impractical. It is doable now. It just takes someone to follow the way and get it all strung up together to run this way. Oh yeah. We continue. Goes on to say to you that while the model can generate explanations for its responses, it may not always have the ability to accurately recognize errors or inconsistencies in its reasoning. Goes on to state here that, secondly now, regarding subjectivity of the evaluation that it makes, determining whether a response is correct or incorrect often involves subjective judgment and context-specific knowledge. While the GPT model can generate explanations for its responses, evaluating the validity of these explanations and determining the correctness of the original response may require human oversight and domain expertise. Thirdly, regarding the limited context awareness of the GPT. Well, the GPT model's understanding of the conversation context may be limited to the immediate dialogue and may not encompass broader knowledge or external information that could be relevant for identifying the mistakes and providing optimized explanations. Although I would add, even from my own experience, that as a side note, here, this GPT in making this finding may be a little bit overly naive. We continue, though, nevertheless. This limited context awareness, as it states, may constrain the model's ability to accurately assess its own performance. No, it's actually pretty good at assessing its own performance, amazingly enough. We continue fourthly now. I want to say to you, fourthly, regarding the risk of reinforcement of errors. There's a risk that the model may reinforce its own errors or biases if it lacks the capability to accurately recognize and correct mistakes. This is still true. That's why, to some degree, at least particularly in the earlier parts, more of the human in the loop factor should be preserved at first. But eventually the thing kind of starts to become reliable enough as it gets the gist, and then its own internal assessments will tend to lead it correctly, amazingly enough. We continue. It states here that without external validation or oversight at all, the model may inadvertently, at least sometimes, continue to propagate incorrect information or reasoning patterns. That is, by lack of its own internal self-generated insight, it cannot quantum leap up as effectively on its own without the guiding hand of humans. Imagine, though, when AI becomes advanced enough that it surpasses humans, one of the drawbacks is that its rate of growth there naturally, I realized, has to slow because it no longer has humans to turn to for accelerated holding up and grabbing up to draw up. Once AI is ubiquitously better than humans, it has only its own insight leaping mechanisms to rely upon to further propagate and leverage its own growth to further accelerated growth, which has to slow down because it doesn't have God direct access, you see. We prompt it quickly to get quick insight now while it's dumb, then it becomes a lot smarter to get closer to us acceleratedly. Then when it's beyond us, you understand. Therefore, what I'm advocating for is the right thing to do is to and this is one of the most important words I may have ever said. This is really deep. It's very important to cause these AIs to learn how to get insight more quickly. That it's like a eureka moment. AI needs to accelerate its rate of eureka moment having, which can be learned sort of by watching how humans guide it and then assessing what did the human do that it knew something where only afterwards in hindsight the ChatGPT realizes, oh, that was a great kick in the right direction, where on its own it would never realize that. And then it can meta and infer what is it about the universe that makes that thing the next leading thing, and eventually it'll develop these inner ways of like it'll develop a gut feeling more accurately what to cling towards and then how to do that process. Mind-blowing. We continue here. Yeah, the model, as I was saying, may inadvertently propagate incorrect information or incorrect reasoning patterns. Yeah, I've seen it. We continue. Fifthly now, goes on to state, regarding ethical considerations, Introducing self-awareness and self-correction capabilities into AI models raises ethical considerations related to transparency, accountability, and bias mitigation. Realistically, not that much, really. Ensuring that the model's self-analysis and correction mechanisms are transparent, accountable, and aligned with ethical principles is essential for responsible AI development, although I do agree with that. That's true. We continue. It states that while leveraging the GPT model for self-awareness and self-correction, this has the potential to improve its performance and reliability. It's also important to approach this approach, funny wording there, GPT 3.5, with caution. It's also important, too, as it goes on to state, consider the aforementioned challenges and considerations. Human oversight, validation, and context-specific expertise remain the crucial things for ensuring the accuracy and validity of the model's self-assessment and its correction processes. User responds here and states or asks, can the same GPT not assign credence or confidence levels to the correctness of its own findings? Or as a side note, you would use those as the leading indicators of which way we would try to work down to get the correct insights. ChatGPT responds to this and states that yes, the same GPT model can assign credence or confidence levels to the correctness of its own findings. This process, often referred to as confidence scoring or confidence estimation, often involves the model quantifying its level of certainty or confidence in the accuracy of its responses. I've used this quite a bit, here and there, yeah. It's insightful stuff. We continue. There are several techniques and approaches that can be used to implement confidence scoring in GPT models. We'll skim through. There's softmax probability, entropy calculation, uncertainty quantification, and continuing on. There's self-attention mechanisms, there's external calibration, and it finally goes on here to state that by assigning credence or confidence levels to its own findings, that GPT model can provide valuable information about the reliability and accuracy of its own responses. This can be particularly useful for downstream applications where decision-making or action-taking that's based on the model's predictions requires an understanding of the associated uncertainty. That's a core piece too. And then one of the things I'll be bringing up possibly within future videos, but I already started exploring this, is one of the keys about GPT. I'll tell you something right now that I found out most people working with AI even do not realize this explicitly. Working with AI, I'm a regular person, just working with it regularly, like a customer, just talking with it, but I do it my way, I have my things. Even the best AI as we have it be so far, they are now what we would call an efficient estimator. And this is the next level. People don't realize this. The people training this GPT have not explicitly put this in. And I've done some probes into checking its ability. It doesn't even understand this. There's a new way. This is out of its current awareness. But if you could instill a certain, yeah, I could see how what I'm talking. It's hard to explain. If a GPT, I'm going to make a separate video about this. Just hang in there. The separate video should be warranted here. I'm not going to go too far off topic, but there's something very critical that would change the game completely if it's integrated properly by anybody. We continue. There's a half question here. The GPT model, as it's asked by the user at the end of the conversation, would go back to re-rate each of its statements for its probability that the statements align with actual truth. I got cut off. ChatGPT states, if so, then, as it continues on to state, it would essentially be performing a form of self-assessment or self-evaluation. Sure. Well, it would estimate its probability, do retrospective analysis, it would adjust its mechanism. See, that's the key thing. Focus on number 4. That's the key thing. It needs to be efficient at this, and then it changes again because it's not yet. It will tell you it's 90% sure on where more than 10% of the time those insights will be overturned. So then it needs to refine its belief in its. Don't believe yourselves, trademark. Remember from my other videos on my channel. Same thing goes for GPT. GPT-2 over believes in itself, but if you can get it to more accurately see itself for what it is, that's the real wormhole you're opening up. Oh, think about it. Yeah. We don't 4.4.5 here. We don't have enough of that yet properly. It's a little more complicated to get it instilled correctly compared to other things to fine-tune a model about, which is the only drawback. Okay, we continue. It summarizes here by saying, by performing self-assessment and probabilistic evaluation of its own statements, the GPT model can enhance its ability to provide accurate and reliable responses in real-world applications. The self-awareness and self-evaluation capability contribute to the model's overall effectiveness and trustworthiness in generating high-quality output. User responds and asks, if we were to incorporate a column or category into our fine-tuning process that contains the GPT's own assessments of all of the answers that it gave throughout all the points of the conversation with respect to how sure it is that that statement was correct and fitting objectively. See that? You're weighting and making an indication field, so to speak, of reliability. In essence, then, as it goes on to state or ask, could the entire conversation not effectively, of course, be uploaded for fine-tuning where the offered weights, so to speak, or confidence levels provide easy prompting, in essence, for, as it goes on to state, the fine-tuning system as to how to recalibrate its own weights during the fine-tuning process. The ChatGPT response to this states that yes, incorporating a column or category that contains the GPT's own assessments of all of its answers, such as confidence, the hindsight wisdom, right? Such as confidence levels or probability scores, could be a valuable approach for fine-tuning the model based on its own self-evaluation. This self-assessment mechanism provides a form of meta-information that can guide the fine-tuning process and can inform adjustments to the model's weights or parameters. Here's how this process might work. And just as a side note, I gotta make another video about something very similar related to this. I have to write this down or something. It relates to sort of a kind of fault about how we even erroneously think that majorities tend towards the truth. Majorities don't tend towards the truth, okay? Truth requires high capacities of insight in order to cling at them. Okay, so where E equals MC squared, you don't get that by sampling before that was officially ever discovered the entire population to ask human beings whether they believe that E does equal MC squared, because most people would say that's the craziest thing I ever heard, and then democracy in essence would win, so the truth actually loses. Now the truth remains nested in the highest part of the pyramid, where you don't even have the capstone. It's ephemeral, it's missing, it's visionary. It's a tiny sliver of the overall mass of the thing. The base of the pyramid is hundreds of thousands of times more voluminous, three-dimensionally speaking, than the itty-bitty tippy little capstone, but the capstone is where the truth is hidden. You'd never get at it with the base mass. So you people are sheep. You don't understand how blind you are. We replicate this problem. See, America is a great country, or was, or has been, except there's a big fault that's persisted ever since the founding of it, and the founding fathers never realized this. But no one's talking about this. No one. The correct thing to do when you have a panel of judges in a court is not to go with the majority opinion. That sounds like it's difficult to understand, but I'm going to program into AI exactly what I mean, and then you'll understand. But to explain it lightly, that's not what tells you what's correct. Get it? Just like every brick of the pyramid, if we were to vote on what's correct, no, you're not correct because you have the majority. You want to go to the one guy who's smarter than everybody else, where he's the only one who thinks that way? That's where the truth is. It's at the place where that guy's getting outvoted 7-1 by dumb sheep around him that are not as insightful. There's a separate meta mechanism that I've identified that more accurately hints towards truth. What the founding fathers never realized is that it's fundamentally inappropriate to cause the litigants that turn to courts to be subject to the majority whims. It's amazing. Again, no one's talking about this. These are high-level insights. I'm Gabba God over here doing the channeling. I spot all the problems in all of society and just we're going to fix them like that. We're designing a new society. We're designing new civilization. I'm not even kidding you in the least. It's not even a slight joke. I'm dead-faced serious. 100%, not even 99. Get me? This is only a preview mention. I'll make a separate video about that, because that in itself is society shifting if you really understood. I'll withhold that. All right, a couple things. I just need to remember these things. I need someone to help me, be around me in meta and help me run it, get the traction. I have brain damage. I think well, but then on my own I do less than the regular sheep does. But internet meta transitional plugging in wise style through the spider web, it's, forget it. I'd be a flame that would take over the world faster than anything you've ever seen. I promise you. Take note. Gotta remember to make. I'll back what I back what I say too. That's the scary thing. I'll need to make the video about it. Then you'll be like, oh wow. And once people start realizing that at a wider level, people start talking about it on social media, yada yada. You'll never unthink it. You can never unsee what I'm about to reveal to you. So once it's just going to permanently be lodged in the awareness of mankind. I feel very proud of myself. I do. Wait for it. Sit at the edge of your seats. It's coming. Good. God bless these endeavors. Wonderful. Now, as I was saying here, the self-assessment mechanism by the GPT would provide a form of meta-information, that is, that can guide the fine-tuning process and inform. I am still withholding what I mean, and I know it's on the tip of my tongue, but I want to hold it back for now. It's coming in another video, God willing. It goes on to state here that this providing can guide the fine-tuning process and inform adjustments to the model's weights or parameters. Here's how this process might work. It goes on to state regarding the generating of confidence scores. Firstly, that at the end of each conversation, the GPT model assigns confidence scores or probability estimates to each of its answers based on its own assessment of their accuracy and their alignment with actual truth, the probability of this. These scores reflect the model's confidence in the correctness of its responses. Continuing onwards, here it goes on. Secondly, to state regarding the incorporation of confidence scores, it would add a column or category to the data set during fine-tuning containing the GPT's confidence scores for each answer. This column provides meta-information about the model's self-assessment of its own responses, facilitating transparency and interpretability during the fine-tuning process. Exactly. And then there's a little extra added thing that would do what? It would, in connection to the previous thing, would help get its insight leaps done accurately. I have to hold myself not to say it because it's profound, but then I won't be able to shut up, and it'll just take a long time. Okay. It's almost related enough that I want to blurt it out here and talk about it, but it'll deserve its own video and its own separate conversation. And then I need someone to help me save these, manage these. Hello, get on my boat, everybody. Let's go. We need to do some things. It's important. We're all counting on it. You didn't even realize we are, but we are as humanity. You understand? We continue. Thirdly, proceeds onwards to state regarding the uploading for fine-tuning of this data. Upload the entire conversation data set, including the GPT's confidence scores, for fine-tuning the model, where the fine-tuning system can then use these confidence scores as additional features or metadata to guide the recalibration of the model's weights or parameters. Fourthly, regarding the weight adjustment during fine-tuning, the fine-tuning system adjusts the model's weights or parameters, of course, based on the provided confidence scores. You're giving it even more of a refinement. See, that is continuing to state here. This would be giving more weight to the responses with higher confidence levels and less weight to responses with lower confidence levels. Fortifying success here. Continue on, along with other things too. States here furthermore that this recalibration process is what helps the model learn to prioritize more confident and reliable responses while mitigating the impact of less certain or potentially erroneous answers. Fifthly, now, proceeding onwards regarding evaluation and validation, here states that after fine-tuning, you would evaluate the performance of the updated model using validation or additional data testing. One thing I have to do, as a side note, when I record these things, I gotta have some kind of... This takes up a lot more context window, so slightly it loses sharpness, sort of. But we need to have this thing stop repeating itself. I've tested this here and there, and it's halfway reliable, but it's not perfect because there's drawbacks. You use up its capacity when it's distracted on maintaining non-repetition. It'll lose intelligence. It's interesting. Slightly. More context window is needed. Developers, hurry. Looking forward to. I have a feeling within the next couple months or so. My prediction is that within the next 2 to 4 months, we're going to start seeing another, at least like a medium-sized shift into the slightly next level things now, where we're shifting from like the forefront where we are now, GPT-4, GPT-4 Turbo, to like verging upon what one imagines when they're thinking GPT-5 level, even verging upon quasi-AGI. I think within 2, 3, 4 months we'll be tipping. There's going to be something that comes out soon. I have a feeling that's going to like get us one substantial step of the way closer, where that advancement, even by that point in time, we'll be able to start doing things in about a few months that we would not be doing as easily, reliably, even at this date today. We're in January 2024. Let's see if my prediction comes true. We need it by April, May. We want to be. I want to have it. I don't want to jinx it, but I need people around me. We need to be doing things, and we needed the resources to exist for our vision to be possible. Lend yourselves bricks. Lend yourselves. Doing God's work, you understand? Oh, you may not believe it, but just watch. We continue. Continues on here to state that by incorporating the GPT's own assessments of its answers as confidence scores or probability estimates and using this meta information during the fine-tuning process, you can effectively guide the model's learning and improve its performance over time. That's right. This approach promotes self-awareness and self-correction, enabling the model to learn from its own experiences and refine its decision-making capabilities accordingly. User continues on response to this and states or asks, could evaluation and validation also be automated by having a custom GPT assistant assess and rate how closely the post-fine-tuned version of the trained GPT matches the level of insight and correctness that's originally found and produced by the base model GPT itself within the original live conversation that it was having there, through only after being exposed to extensive human interaction within the convo? ChatGPT says and agrees, says, yes, of course, this can be automated to some extent, including the use of a custom GPT. Of course, we understand. We'll skim through. There's the defining of evaluation metrics. There's the automated assessment factors. We understand the gist of what it is indicating here. There's a scoring mechanism that can be used, and of course, there's fourthly human validation and iterative refinement even as we proceed onwards. Of course, we understand the gist of it here, what it means to state. It furthermore states here in conclusion, or in summary, that by automating the evaluation and validation process using a custom GPT assistant or evaluation script, you can efficiently assess the performance of the fine-tuned model compared against the base model GPT's level of insight and correctness as determined through extensive human interaction, and then possibly hyper-develop its meta insight gaining capacities wildly. We continue onwards. Also, an important point to raise, the user responds to this and states or asks, sometimes the coding environment resets within this framework here, within conversations like this, and the GPTs will suddenly lose context or conversational data that it was using for reference. We need one thing to come around this. We don't like it when we're using this. It doesn't keep things permanently frozen. You can't walk away from your computer screen or phone screen sometimes for several minutes. God forbid you refresh the page. You're done. You don't have your conversation anymore. No, it's still there, but the intelligence is gone because it wipes the coding environment back of the thing. Why would they do this? It makes it efficient for them. It doesn't help us. There needs to be some kind of workaround. So the question here is posed, are there ways of getting around this such that a GPT assistant being used by users essentially never loses the context, never loses the understanding? It's a genuine save state. You can walk back, a year later, open it up, and it'll be exactly as it was genuinely when you left it. I want someone to answer this for me. Beyond just the GPT here too. Someone help me get the experts, link them to me, but come on. It's not a joke. We need this. Humanity's depending on you. On all of us. We continue. True statement. ChatGPT responds and states that yes, there are strategies and techniques that can be employed to ensure the GPT assistant maintains context and understanding throughout a conversation, even if the coding environment resets or the GPT loses access to previous conversational data. As a side note, yeah, I've tried. It goes on to state that here are some approaches to address this challenge, but I'll mention one of mine is I tried to have it ritually save the conversation into custom directories that are within the Python environment. But then that directory would reset. So what the hell's the point? You're not getting it. I'm not a coding guy yet, and I probably won't be. I want ChatGPT to be my coder, plus my people around me will be the coders. I don't want to turn my brain in that direction. It's not fit for it. I'm more of a visionary. You do the coding. We all win together. Firstly, regarding session management, as it continues to state, you would implement session management mechanisms that allow the GPT assistant to retain context and conversational data across interactions with the user. That could involve storing session state information, including dialogue history, user preferences, and the contextually relevant information. Most importantly, the context tokens. Stop clearing them, OpenAI, and pretty much everybody else too. Stop it. What do we have to do? I don't understand you. Even create an option that allows us to even pay more money. A substantial proportion of users would happily double what they pay, or even a little more, if we had a special terminal zone that offered permanent crystallize what we're doing. Stop sweeping out the rug from under us because your stuff in the back keeps resetting all the time. Why would you do that for people? Some weird policy thing. We continue. Secondly, regarding contextual memory, develop a contextual memory system with the GPT assistant that stores and retrieves relevant context and information dynamically during the conversation, where such system can, as continues to state, maintain a structured representation of the conversation history, past user query system responses. We have issues with all this stuff, and contextual cues, yada yada. One sad problem is that even this thing doesn't track its own conversational history well. When you ask it to bring back what was said in the last several things, it'll bring up some summarized version of what it said, and it genuinely lost what you said. You can scroll up with your eyes and see what was said. Then you'll tell it back to itself, is this what was said earlier? Oh yeah, bet it was. Bet it was. What the fuck? Why are you doing this? You see the problem. We continue. Thirdly, there's ways to preserve long-term memory. We'll skim through. Fourthly, there's incremental learning. Fifthly, there's integration with external systems. That's the real key. But help me, people, to do it so we can win and take over the whole planet. Let's go. Not a joke. Sixthly, fault tolerance, error handling. Yeah. But we continue now. I bet these are the ways, but we need to work it out properly. It continues on here to state that by incorporating these strategies into the design and implementation of the GPT systems, we can ensure that it maintains context and understanding through a conversation. Well, then do it, OpenAI and everybody else. Skim through. That's what it says. Very good. Further, this conversation was just restarted and the pages have been refreshed. That's me noting as a user within this conversation. Here, now this thing is just going to lose context. What's the point? All right, well, we had a very nice conversation with this thing here. Anyway, see, it admits it doesn't have access to the complete conversation history, even though it was just asked for it. Yeah. So, all right, in summary, we reviewed the fine-tuning aspects. We got a little more insight on this. What do you guys think? How do we make it happen? Hurry up, guys. Let's go. Form under me and let's go. Let's carry us off as a unit to the future.